50, I'm sorry, minus 50, minus 50, minus 50, 0, and looking at this list, minus 50, 0, 0, 0, 0, we see that the deviations from the mean here are much bigger than the deviations from the mean here. And that's what we wanted to say. We wanted to say up here that the deviations for A, or the spread for A, is bigger than the spread for B. And we're getting that here when we look at the deviations from the mean. Now, we don't really though. Okay, so that would be good enough. We could just stop here and say, okay, now we can say that the deviation from the mean for A is bigger than the deviation from the mean for B. And that could be our justification for saying that A is more spread out than B. But we'd like to get a single number, not a long list of numbers. Okay, we'd like to say, oh, the deviation for A, let me just call it deviation for A, is equal to something, like maybe it's equal to 30, or just some number, and then the deviation for B is equal to some number, maybe it's only 5, and therefore this one is bigger than this one, therefore it's A has more deviation than B. So I don't want a list, I want a number. So how can we get a number out of this list? How can we get a number out of this list? Well, we could just take the average of these. That's kind of a summary of these. And we could take the average of these. And that sounds like a good idea, but it doesn't really work, because when you take the average of these, what do you get? You're going to get 0 for the average of these, because here you have minus 50 and plus 50. Minus 50, and you're going to get 0. And same thing here, you're going to get 0. So you're going to get if you use that, you would say, oh, the deviation for A is 0. And the deviation for B is 0. That doesn't work, even though A and B don't have the same spread, but this says that they have the same of whatever we just calculated. So that's not the best thing to do. So instead of doing that, what they do is they don't just take 50. You could take the absolute value of negative 50, negative 50, negative 50 will be 50, 50, 50, that would be fine. And you could take the absolute value here, and that would be 50, and then you wouldn't get that cancellation. That would work just fine. But I don't know if you remember, but in algebra, when you do things like, something like this, and you have to work with the absolute value sign, it doesn't work very well. It's a very messy, tricky, and hard to deal with. So we don't really want to use the absolute value, because we're going to be having to do calculations based on this. We don't want to have to deal with the absolute value. Another way to get rid of negatives is to square, right? If you take negative 15, you square, you get a positive number, and if you take positive 15, you square, you still get a positive number. So that's what we do. So we take the square of this, and that's what we calculate. So we get another, I should have put that over here. I shouldn't have squared it there. But anyway, we put that over here. So we get 2,500 here, 0, 0, 0, 0, 0. I'm sorry, 2,500 here. And then over here we get more writing, 2,500, 2,500, 2,500, 0, 2,500, 2,500, and 2,500. And now, if we take before we took the mean of these numbers, and that gave us 0. But now when we take the mean of this, we're not going to get 0. Well, what are we going to get? This is 3 sets of 2,500 is 7,500, another 7,500. That's 15,000. And if you take the average of 15,000 divided by their 7 pieces of data, so that the mean of this is going to be what? About bigger than 2,000. So let's just say it's bigger than, let's say maybe it's about 2,150. And the other one, now suppose we do the other one, that is going to be, so here we have 2,500 and then only zeros, and then 2,500, that's 5,000. over 7. So that's only going to be what? About 720 or something like that, just making a wild guess. Anyway, whatever it is, it's much smaller than this number, which is what we wanted. We wanted to say that the spread of this is much bigger than the spread of this, and this is what we're using to measure the spread of this one. Oh, sorry, didn't work. This one, and this is what we're using to measure the spread of this one, and this one has much bigger spread than this one, which is what we want. So that is how we do it. So what did we do? We looked at the deviations from the mean, and then we squared them and did their average.